Hello and welcome to Repair Solution Pro how-to video series. My name is Eli Saldana and
I'm Steve Caruso.
And in this video we're going to walk through the entire diagnostic and repair process for DTC P1101 intake airflow system performance on a 2014 Chevy Cruze. Let's go ahead and get moving on that. After gathering the information, perform an initial inspection and check for any obvious mechanical issues such as damaged or improperly installed or collapsed intake components, airflow restrictions or a restricted air filter, splits, kinks, leaks, or improper connections in the vacuum hoses, vacuum leaks in the intake manifold, map sensor, or throttle body, water intrusion, contamination of the map sensor element. Inspect the intake manifold pressure, air temperature sensor, multifunction intake air sensor, and turbocharger boost sensor for proper installation and any visible damage. Next, you want to refer to the service manual or any applicable TSB, including 18-NA-118 or 20-NA-047 before continuing with the diagnosis of this diagnostic trouble code or DTC. Now that that's done, we can scan for codes and continue the investigation.
Once the visual inspection's been complete, put the key in the key on, engine off position and use the scan tool to check for DTCs. In this case, we have DTC P1101 intake airflow system performance, typically caused by an improper airflow during warm-up due to a dirty or faulty throttle body. Then, check the freeze frame data and review the service history and look for any TSBs. Now, let's take a closer look at what could be causing this code.
Now, with code P1101, there are several possible causes, including dirty throttle body, possible map or faulty map sensor, faulty map boost pressure sensor, vacuum leak in the intake manifold, map sensor, throttle body, plugged PCV system. There's a lot of things that could be wrong.
All right, so first we need to run a few tests to figure out exactly what's causing this code. Let's go step by step. Step 1, check crankcase pressure evaluation for L3A, LE2, LFV, and LYX engines. Evaluate the crankcase pressure on engine. With the engine at normal operating temperature, the transmission in park, and the engine idling, crankcase pressure should typically measure between -1 and -5 inches of water. This measurement can be taken through the dipstick tube using a manometer. In this case, the crankcase pressure reading falls within specification, indicating that the positive crankcase ventilation PCV system is operating as intended. Continue to the next diagnostic step. However, if your crankcase pressure reading is outside the specified range, especially if it is positive or above 0 inches of water, inspect the PCV system for restrictions or failures. Positive crankcase pressure can lead to oil leaks and seal damage. Repair or replace the PCV system as necessary, then perform repair validation. Inspect the throttle body by checking the idle airflow compensation value. It should be below 50%. Ideally, it should be between 10 and 20%. In this case, the value is within specification, so move on to the next step. However, if the value is high, clean the throttle body and perform a throttle body adaptation using a scan tool. Then perform the repair validation. Step 3 is to inspect a mass airflow sensor. Using scan data, start the engine and monitor the mass airflow sensor values. The reading should increase smoothly as the engine RPMs increase. If the values do not respond properly, or if the voltage value drops below 0.46 volts, replace the mass airflow sensor and perform a repair validation. If the values respond properly, proceed to step 4. Step 4 is to inspect the map sensor and the boost pressure sensor. Turn the ignition on and monitor the map sensor and the boost pressure sensor values using the scan tool. If the values do not match, replace the map sensor or the boost pressure sensor and then perform the repair validation. If the values match, then continue on to the next step. Turn the ignition to the key on engine running position and monitor both sensors again. They should respond when the accelerator pedal is pressed. If the values do not respond properly, replace the map or the boost pressure sensor and then perform the repair validation. If the values respond properly, continue to step 5. To check for possible vacuum leaks, we'll use a smoke machine. First, disconnect the intake duct near the throttle body. Next, install the smoke machine adapter and make sure the system is properly sealed. Once everything is set up, turn on the smoke machine and allow smoke to fill the intake system. Then, inspect the system for any signs of smoke escaping. Here we found that the intercooler is leaking. You can see smoke from there. We've confirmed that the intercooler hoses are leaking, so we're going to replace them. Follow these step-by-step instructions and remember to wear the appropriate PPE throughout the procedure. There are 2 primary hoses in the charge air cooler system. The inlet hose, which is hot side, located in the upper left area of the engine bay. This hose routes high temperature, compressed air from the turbocharger outlet to the charge air cooler. The outlet hose, which is cold side, located on the opposite side of the charge air cooler. This hose routes cooled air from the intercooler outlet to the engine's throttle body. First, remove the charge air cooler outlet hose. Disconnect the turbocharger pressure sensor electrical connector. Then loosen the clamp and disconnect the charge air cooler outlet hose from the throttle body. Raise the vehicle and remove the lower engine cover for access. Unclip and disconnect the charge air cooler outlet hose from the charge air cooler. We're going to remove the charge air cooler inlet hose. Loosen the hose clamp and disconnect the charge air cooler inlet hose from the turbocharger and unlock the quick connector at the charge air cooler. Raise the vehicle for access if necessary. Remove the charge air cooler inlet hose from the vehicle. Let's install the charge air cooler outlet hose. Cold side intercooler hose. 1. Connect the hose to the charge air cooler and secure it in its retaining clip. Next, connect the hose to the throttle body and tighten the hose clamp. Lower the vehicle and reconnect the turbocharger pressure sensor electrical connector. Next, install new charge air cooler inlet hose. Hot side intercooler hose. Start by connecting the hose to the charge air cooler until you hear the quick connector click into place. Lower the vehicle, then connect the hose to the turbocharger and tighten the hose clamp securely. 3. Install the lower engine cover, lower the vehicle and close the hood. After replacing the intercooler hoses, perform repair validation to verify that the repair fixed the concern. First, use a scan tool to clear all stored trouble codes, freeze frame data, and I&M readiness information from the vehicle computer. Next, start the engine and leave the vehicle in key-on engine running position. Check the comprehensive component monitor and make sure the monitor is enabled and showing green-gray on the scan tool. After that, complete the required drive cycle. You can follow the drive cycle steps shown on the scan tool or use the procedure listed in the service manual or emissions guide. This allows the OBD system to rerun its self-checks and verify the system is working properly. Once the drive cycle is finished, use the scan tool to check the I&M readiness monitor status and look for any pending or confirmed trouble codes. If no codes return and the readiness monitor shows complete, which is green, the repair has been verified and the issue is fixed.
This concludes the entire process for fixing P1101. Thanks for watching. For more information, please visit us at pro.repairsolutions.com.